Hi, I'm Jack Buffington for RobotBrigade.com. This is another video in my series of videos about digital logic, and in this one I'm going to talk about parity and parity circuits. What is parity? Parity is a, generally it would be a single bit in a packet of data. Generally packets are 8 bits, but it doesn't really matter how many bits it is, especially if you're rolling your own digital system. And there are two types. There's even and odd. And let's take, we'll make a 8-bit number here. And even parity says that the number of bits in a group of bits must be even. And so in this case we have 5, I should say the number of high bits must be even. In this case we have 5 ones, and so if we have a parity bit, it needs to be a 1 as well to make it even parity. If I have the same number and I'm using odd parity, then I'll make it a 0, because that ensures that the number of ones is an odd number. So pretty simple concept. Let's take a look at a circuit that does parity. Now you might think that this would be a very complicated one, but it's not at all. We'll start with the simple case of just 2 bits. There we go. That's our parity circuit. It's an exclusive OR. And so if I have a 0 and a 0, well, the number of ones is even, and so I don't need anything, and so out of here would be a 0. If I have a 1 and a 0, or a 0 and a 1, then the output of this would be a 1, because it's exclusively OR. So 1 and 0, they have to be opposites in order to get a high out of this. Alright, so we get a 1, and if it's a 1 and a 1, then we already have 2 high bits, and we're going to get a 0. So this is generating a even parity. Okay, what about if I want to expand this? Let's go to 3 bits. Well, it's still very simple. We just take it like this, and out you go. We have even parity coming out of here. If we want to go to 4 bits, we can just tack on another. Alright, and it's still even parity. Well, as we start adding on bits, we start to get a bit of a gate delay going. So this maybe stacking them up in a string like this isn't necessarily the best way. So let's expand it to 5 bits. Or actually, we'll do 4 bits another way. We have an exclusive OR here. And we still have even parity coming out of here. Alright, let's say that you're really sick of even parity and you want to get odd parity. Well, there you go. Now it's odd parity. And maybe you're feeling really wishy-washy and you want to be able to choose on the fly which parity you're going to get. Well, we're just going to stick another exclusive OR on there, and this is our Parity Select Bit now. So if this is a low, we get even parity. And if it's a high, we get odd parity. And it's really just that simple. Parity is a very simple circuit to implement. It really takes no real thought. Alright, so that's parity. If you enjoyed this video and you'd like to learn more about digital logic, take a look at my YouTube channel. For RobotBrigade.com, I'm Jack Buffington.